And now for a change of pace. We're going to put the graphs aside for a little bit and just play with exponents. So you'll remember that there are several laws. There's a product law and a quotient law and a power law and the negative thing, the inverse, whatever. If you need to remind yourself of what the power laws are, I have posted a link to a printable worksheet that has all of them listed on it. I'm also going to be scanning that just in case the link doesn't work for you. So you'll have those ready and waiting, available for you. I prefer that you don't use those when you go into a test situation because you really should know them. Besides, you've already got a huge cheat sheet for this chapter anyway. So for now, we can use the cheat sheet, and what we're going to do is solve these. So when it says solve, solve always means actually find the numerical value for x. So first thing we need to do is find a pen that works. I think this one's going to do it. This says 2 to the power of something equals 1 over 128. First thing I'm going to remember is that if I have an inverse relation like this, that guy's a negative. So I can even just write 2 to the negative x equals 128. That way it simplifies it for me. I know that there's going to be a negative here because that's how this flippy thing happened. And now I just have to focus on 2 to the power of what is 128. You could go through this a few different ways. You could just multiply by 2 until you get to 128, or you could guess and check. But you'll find that you get 2 times 2 is 4. That's 1. Or actually, that's squared. Times 2 is 8. Times 2 is 16. Times 2 is 32. Times 2 is 64. Times 2 is 28. So it's 7. So 2 to the power of negative 7 is going to equal 1 over 128. So we have x equals negative 7. That one was fairly straightforward because you've already got one that's the base that you're looking for. B gives us one where we have 2 different bases. Now we can't work with 2 different bases. It's not possible. They have to be the same number. So what we look for is, can I go 4 to the power of something is 8? The answer is no. 4 times 2 is 8. That's not a power. What I want to do then is look and see if I can reduce 4 to a simpler base. And 4 is 2 squared. So we'll start there. I'll rewrite this, 2 squared to the power of x. And then I want to know if 8 can also be reduced to something base 2. 2 to the power of what equals 8? Well, that's 3. So 2 to the power of 3 is going to be x minus 1. We can work with this because the bases are the same. Now we just have to look at the exponents. This one, knowing the exponent law, where if I have something in brackets with an exponent raised to an exponent, I multiply those exponents. I can actually ignore the bases and recognize that the exponents will have to be equal because the bases are equal. 2 to the power of this equals 2 to the power of this. Well, it must be the same power or it wouldn't work. So I can go 2 times x equals, and this is 3 times x minus 1. So I would write that 3 times x minus 1 like that. Now I'm ignoring the bases now because I know that the exponents are the things that have to be equal, and I can just simplify the equation. 3 times x minus 1, you have to multiply the 3 through the brackets. Lots of people will make the mistake of just going 3 times x and then leaving the minus 1. That's not what you have here. You have 3 x minus 1s, which means you have x, 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 and minus 1, minus 1, minus 1. So you have 3x minus 3. Essentially, you have to multiply whatever's outside the brackets by each of the terms inside the brackets, not just the first one. Now we have 2x equals 3x minus 3. So I don't like negatives. I prefer to avoid them if I can. So I'm going to move this 2x because I want my like terms on the same side of the equation. I'm going to move this 2x over, and I'm going to move this 3 over that way. Now this is a negative 3, so when it comes across it becomes a positive 3. This is a positive 2x, so it becomes a negative 2x. So I've just rearranged my equation. if you don't follow why I did that, you might want to look back in grade 2, I think it was, when you had fact families like 3 minus 1 equals 2, 3 minus 2 equals 3. You can just switch those places and you end up with the same pattern. So 3 is by itself, 3x minus 2x is simply x, and there you go, x is 3. Now if you wanted to, you could substitute the 3 back into the original formula and see if it works. So let's do that. 4 to the power of 3 equals 8 to the power of 3 minus 1. Well, 3 minus 1 is 2. 8 squared is 64. And 4 times 4 is 16 times 4 is 64. So we can get our value and then we can plug it into the original equation to check to make sure that we're right.